The function y equals a times b to the x power can model exponential decay as well as exponential growth. In both cases, b represents the rate of change. The value of b tells if the equation models exponential growth or decay. Key concept: exponential decay. Definitions: exponential decay can be modeled by the function y equals a times b to the x power, where a is greater than 0, and 0 is less than b, which is less than 1. The base b is the decay factor, which equals 1 minus the percent rate of change expressed as a decimal. In algebra, we can see the variables labeled, a being the initial amount, b being the decay factor, and x the exponent. Graphically, we see a similar graph to exponential growth, except that this one is decreasing in terms of its y value, or its output value, as the input x increases. So as we move to the right on the graph, our values decrease, but decreasing more and more slowly as x values increase. Problem 3, modeling exponential decay. Physics. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases by about 11.5%. What is the approximate pressure at an altitude of 3,000 meters? Well, we'll use the exponential function, general form, y equals a times b to the x power. We'll define our variables. We'll let x equal the altitude in thousands of meters, y the atmospheric pressure in kilopascals, a the initial pressure in kilopascals, 101, and b the decay factor, which is 1 minus 0.115, and that's 0.885. Substituting into our formula, we have the equation y equals 101 times 0.885 raised to the x power. Now we're going to use this equation to estimate the pressure at an altitude of 3,000 meters. So we'll substitute 3 for x. Remember, x represents thousands of meters. So y equals 101 times 0.885 to the third power, and that's approximately 70. So we can now state the pressure at an altitude of 3,000 meters is about 70 kilopascals. Your turn. Part A, physics. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. What is the atmospheric pressure at an altitude of 5,000 meters? And part B, a reasoning item. When modeling exponential decay with an exponential function, why do you subtract the percent decrease from 1 to find the decay factor?